Hi, let's take a look at inscribed angles in a circle. An inscribed angle is an angle whose vertex is on a circle and whose sides are chords. You can see it, we have two inscribed angles. First one is angle SUN, the second one is angle DAY. An intercepted arc is the arc that is formed by the angle. So angle SUN intercepts arc SN, and angle DAY intercepts arc DY. Unlike central angles, these inscribed angles have their vertex on the circle and not in the center. We can have inscribed angles formed by two chords or a chord and a tangent. So we're going to combine them together. Any angle whose vertex is on the circle is equal to half the measure of the intercepted arc. For our first example here, this is an inscribed angle. Angle PQR is going to be half of arc PR. So the first thing we need to do is find what arc PR is. We know that the whole circle is 360 degrees. So if we add 60 and 130 and subtract from 360, we get 170 degrees for arc PR. And angle PQR, since it's inscribed, is half of that. And half of 170 is 85 degrees. This inscribed angle is formed by a chord and a tangent, forming this angle right here, XYZ. That's going to be half of arc XWY. Again, we'll start by subtracting 100 from 360. That's going to give us 260 degrees for arc XWY. And then half of 260 is 130 degrees. Right, let's take a look at some corollaries that go along with inscribed angles. Our first one says if two inscribed angles intercept the same arc, then those angles are congruent. It might be helpful to highlight angle CDF and angle CEF. Those are the angles that we're looking at. They are both going to be half of 82 degrees, so they're both 41, because they both intercept arc CF. So anytime you have two inscribed angles intercepting the same arc, they're going to have the same measure. Our second corollary is an angle inscribed in a semicircle is a right angle. Both angle GJI and GHI are inscribed in semicircles, so they're 90 degrees. And we know that they're inscribed because if I follow the sides of the angle, they hit at the diameter. So let's find what they're asking here. The measure of arc HI right here, well, we know this is a semicircle, so it's 180, and 180 minus 65 is going to be 115 degrees. We can do the same thing to find GJ. This semicircle is 180 minus 150 would give us 30 degrees for JG. And then the measure of angle GHI would be 90 because it's inscribed in a semicircle. And our third corollary, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So that means the angle here at A and the angle here at E have to make 180, as well as the angle here at L and the angle at K have to make 180. First thing we want to do for these examples is find AL. Again, we would take 360, subtract 110, 130, and 52. That would be 68 degrees for AL. Then we're looking for the measure of angle LEK. LEK is this angle here. And if I follow the sides of that angle, it forms this entire arc, 68 plus 130, which is 198. This is an inscribed angle, so it's going to be half of that. So that's angle LEK here is going to be 99 degrees. Now we know that that's 99. We know that angle A across from that is supplementary to that. So 180 minus 99 would be 81 degrees for angle A. And then we're looking for the measure of angle AKE. That's this angle right here. Again, if I follow the sides of that angle, it's forming this whole arc, ALE, which would be 178 if I add 68 plus 110. And then since that's inscribed, it's half of that. So half of 178 is 89 degrees for AKE. And again, these opposite angles make 180. So 180 minus 89 would be 91 degrees for angle L. Let's take a look at a few more examples. In number 1, we're looking for X, Y, and Z. The first thing I notice is that angle X is intercepting the arc Z, and this 20-degree angle is also intercepting the arc at Z. So that means X has to be 20 degrees because it has to be the same as this angle here. If I look at Y, if I follow the sides of Y, they are hitting the diameter. So that means Y is inscribed in a semicircle. So Y is going to be 90 degrees. And then Z is the arc that is intercepted by this inscribed angle. So Z is going to be double that. So Z would be 40 degrees. For number 2, it does say X and Y are not congruent. This is just showing you that you're looking for that whole angle. There are a few different ways you could go about this one. The first one, I notice that I have a 60-degree angle here. If I trace that 60-degree angle out, it's intercepting this arc here. So this arc would be 120, and then X is an inscribed angle there. So X would be half of that. So X would be 60 degrees. Now that I have 2 out of my 3 arcs, I can add 140 and 120 and subtract that from 360 to get that this arc down here is 100. And then Y would be half of that. Just like X was half of 120, Y would be 50 because it's half of 100. And then Z, if I follow the sides of angle Z, Z is intercepting that 100 degrees, so Z would also be 50 degrees. It would also be half. All right, now let's take a look at number 3. If I'm looking for X, X is this arc here. A lot of people will try to say that it's 180, but it's not. This chord is not going through the center of the circle, so you have to be careful there. X is the arc formed by this inscribed angle, so X is double that, so that's 160. And then I noticed that Y and Z, both of those arcs are formed by chords that are congruent. They're both 15. So that means Y and Z have to be equal. So if I take 360 minus 160, I get 200, and I can divide that by 2. So both Y and Z would be 100. And for our last example, we're again looking for X. The whole circle is 360, so we can subtract 80 and 120. So X here would be 160 degrees. And then Y is a central angle, so it's equal to the arc that it intercepts. So Y would be 80 degrees. And then Z is an inscribed angle, which would be half of the arc that it intercepts. So Z would be 40 degrees.